How are you, everybody who is watching this workshop? I'm very happy to have you today, and I would like to take this opportunity to welcome you into a very interesting workshop, and especially that we call them just lectures or workshop, but it will focus on telecommunication engineering. My name is Olenjolai. It's the first time to meet me. I'm very happy to have you today. We have a module that called the Radar Navigation Aids. This is the modules that we are training NTA Level 5 or second year ordinary diploma in electronics and telecommunication engineering. So if you are a telecom engineer or just technician or electronics engineer or technician, just make a follow-up because we are going to discuss very important information in the field of electronics and telecommunication engineering. So I have some physical students in this class, and I would like to appreciate their presence. But for the online, this is the kind of more theoretical module. We can have a study visiting that just will go to different places. So let me just ask you to join us into this interesting part. How are you, students? Yes, they are fine. Are you ready for workshop 4? Yeah, wonderful. Do you enjoy radar and navigation aids? Yes. Tell your neighbor, welcome to learn radar and navigation aids. Hey, tell your neighbor, welcome to learn radar and navigation aids. So we are still in chapter 2, Introduction to Radar System, or Introductions of Radar System. And this is workshop 4 that called Types of Radar System. So before I introduce you about types of radar system, let us do the quick review of workshop 3. What did we discuss in workshop 3? So in workshop 3, simply we discussed about TOTI. The title is called the Terminologies of Radar System. Terminology of radar system. The first, one of the terminologies that we discussed that day, it's called what? Range. What is range? What is range, class? Range is the distance, from what? From the radar site, to the target, but measured along the line of what? Line of sight. It means the radar system should be in line of sight with the target. Then in this range, we say that we can calculate it mathematically. We introduce also the mathematical formula. Then with mathematical formula, what we deduce, the range is equal to what? Class, range is equal to what? Is equal to the speed of the light multiplied by what? Time divided by what? By 2. Why it is 2? Because 2, actually in case of range, we have the distance from the radar to the target and the distance from the target to the radar. Because a radar system has to receive a reflected wave. Right? Then the next parameter that we discuss is called what? Radio velocity. Radio what? Velocity. And what is radio velocity? I gave you two definitions of the word radio velocity. What's radio velocity? I don't hear you. What is radio velocity? So this is the component of what? Component of who? Speedy, windy velocity. Component of windy velocity. How many types of radio velocity do we have in radar system? Two. The first one, outbound radio velocity, and what? Inbound radio velocity. Inbound, outbound, and the inbound radio velocity. What is the difference between inbound and radio velocity? I didn't ask you to define. What is the difference between outbound radio velocity and inbound radio velocity? The difference is directions of what? A target. Right? Inbound, the target is moving towards what? Moving away or towards the radar. Towards the radar. Outbound, moving what? Away. Then another terminology is what? Elevation angle. There are another parameter we discussed, it's what? Azimuth angle. So we discussed a lot of the information. This is just a summary and quick review. So in case you missed it, access workshop 3 that titled the terminologies of radar system. So today, let us move on where we ended in previous session. So we have types of radar system. Say types of radar system. So types of radar system. So we have different types of radars in telecommunication engineering. So types of radar systems, we say that so the classification of different radar system depends. The classifications of different radar system depend upon what? Upon the technique. Depend upon the technique or the techniques used. Upon the technique used. Upon the techniques used. Used for the measurement. For the measurement. Upon the techniques used for the measurements or measurements of radar parameter. Radar parameters. So we used to categorize or to classify different types of radars by depending on the techniques used for the measurements of radar parameters. So it means that we can have different, let's say we can have 3 types or 2 types of radars. But those 2 types of radars, how did we classify them? Depending on the techniques of measurements, radar parameters. Say radar parameters. Say radar parameters. So the radar parameters, if you do remember that, what I taught you in previous workshop or in previous lecture, do we call them workshop or lecture? Something like, I think that lecture, because this is your. So we said that radar parameters, if you do remember, radar parameters are, the first one, we say that range. This is the one of the important radar parameter. The second one, we call it what? radio velocity. Say radio velocity. Then the third one, we call it elevation angle. Say elevation angle. Then the fourth one, or the fourth radar parameter is what? Azimuth angle. These are the four main radar parameters. These are the four main radar parameters. So it means that these four radar parameters are the ones we use to classify or to have different types of radar system. So depending on what the technique used to determine range of the target. Stop writing. So with these four, we can have, let's say that we are going to have two main types of radar system. But how did he categorize those two, and how did he categorize the two types of radar system? Depending on what the technique used in the first type of radar determined the range of the target. What the technique used by that first type of radar determines the radio velocity. What the technique used to measure elevation angle of the target. What the technique used to measure azimuth angle of the incoming target. So these are the conditions, the four conditions that we are using on classifying different types of of radars. Are we together? Are we together? Yes. Okay. So according to these measurement parameters, we say that in telecommunication, engineering, there are two main types of radar system. There are two main types of radar system. Namely, the first one, we call it primary radar system, or primary radar system. And the second one is called the secondary radar system. Class A primary radar system. Class A primary radar system. Class A secondary radar system. So the difference between these two types are these two main types, because we call them main types. The difference between them is just the technique used to measure range, radio velocity, elevation angle, and azimuth angle. It means there are the different techniques that have been used. So the techniques used to measure range in primary radar system is different from the techniques used to measure range in secondary radar system. Stop writing. The technique used to measure radio velocity in secondary radar system is completely different from the techniques used to measure radio velocity by using primary radar system. The technique used to measure elevation angle in secondary radar system is completely different from the technique used to measure elevation angle in primary radar system. The technique used to measure azimuth angle by using primary radar system is completely different from the technique used to measure azimuth angle of the moving target by using the secondary radar system. Is it clear? Is it clear? Yeah. So then we have primary radar system. Let us categorize. So then we have again types of primary radar system. Let me just give you the general concept. Types of primary radar system. Types of primary radar system. So again, we say that in telecommunication engineering, there are two main types of primary radar system depending on, so we have another additional features here or factor, depending on what? On transmitted radio frequency and the echo RF signal or RF radio frequency wave or RF wave. So remember that we classify also primary radars based on the techniques used to measure the radar parameters. Okay? So remember that. If that's the case, we say that we are going to have two main types of of primary radar, but we have against another additional factor. And the additional factor that we are going to have is the dependence of transmitted radio frequency and the echo radio frequency. So transmitted radio frequency means that we say it depends the type of radar. In radio frequency, you have different bands. So, and echo, this is the reflected, because what you'll be transmitting is what you expect it to be an echo. So echo is a reflected wave. So reflected what? It's a reflected what? Echo. So echo, simply say that is a reflected wave. So why should we mention about transmitted radio frequency and the reflected radio frequency? Because this one, which is its echo, which is reflected, we say it's a one we use to get the information about the range of the target. It gives us information about the azimuth angle. It gives us information about what? Elevation angle. It gives us information about what? Radio velocity of either incoming or moving away target. Are we together? Are we together? So it means that these are the four factors, but here we have a fifth factor. The type of transmitted RF and the echo. So for this case, we have two types. So the first one, we call it continuous. So continuous. The first type of primary radar system is called continuous. We call it continuous primary. So continuous radio frequency RF wave primary what? Primary radar system. Primary radar system. Simply, this we call it continuous wave. In short, we call it CW radar system. So in short, we call it CW radar system. CW radar system. Say continuous wave. Or say continuous radio frequency wave. The second type is called the pulse. So it's called the pulse radio frequency wave. Radar, primary radar system. Primary radar system. Simply this one in short we call it PW. PW radar wave. Radar system. So PW is abbreviations of pulse wave. Say pulse wave. So the main difference between these types of primary radar system, this is actual, the radar system will be sending continuous radio frequency. In the second types, the radar system will be sending pulses. Say pulse. Say pulse. So it means that it will send pulses. And then for the first type, it will be sending continuous signal. So you know continuous signal, it means that it might be either we say call it sinusoidal signal. This is the continuous signal. Pulses, when you say that it will be sending pulses, it depends. Sometimes the width of the pulse might be different. So this is the shape, waveform of the pulses. So you might find that there's a difference between these transmitted and the reflected signals. Are we together? Yeah. So they are using different techniques of measuring the radar parameters, but also the shape, the waveform of the transmitted and echo radio frequency signal is different. Are we together? Okay. Do you have any question of that part? Eh? Do you have any question concerning about what we have discussed? No. So we can categorize furthermore about what, about types of what, or we can break down and come up with two types of continuous radio frequency wave and other two types of pulse radio frequency wave. So for that case, we say that types of what? Types of continuous RF or radar system. Types of continuous radio frequency wave radar system. So again, we classify them depending on another 60 factor. The 60 factor that we can classify these types of continuous radio frequency wave, the 60 factor, we call it is either the transmitted radio frequency wave or the echo radio frequency wave. Is it modulated or unmodulated? So it means that the 60 factor to classify the types of radar is either the transmitted radio frequency wave or the echo radio frequency wave is either modulated or unmodulated. So in radar system, there are two types of what? Of continuous CW, continuous, let's say continuous radio frequency wave or CW radar system. So this one, namely what? So you can name them. Namely the first one, we call it modulated continuous radio frequency wave radar system. Then the second one, it's what? Unmodulated continuous So unmodulated continuous radio frequency wave radar system. So these are the two types of continuous radio frequency wave. Class A, modulated continuous radio frequency wave radar system. Again. Again. RF. What the long terms of RF? Then say unmodulated continuous radio frequency wave radar system. Zero frequency. So types of what? So also we can categorize the type, the pulse radio frequency radar system into two. So types of what? Pulse radio frequency radar system. Types of pulse radio frequency radar system. So in radar system, there are two main types of pulse radio frequency radar system. And this we name them. The first one is called the moving target indicator. Moving target indicator, and the other ones we call it Doppler pulse Doppler radar or Doppler pulse radar. So the first one is called the moving target. Let me check the spelling. Moving target. Moving target indicator. In short, we call it MTI. And the second one, so moving target indicator pulse RF radar. The second one is called the Doppler pulse RF radar. So there are two types of pulse radio frequency radar system. And these we categorize them according to the whether that there are the target, or whether that the indicator of the target is moving, or the indicator of the target is actual uses just Doppler effect. So we have two types of pulse radio frequency radar. The first one is called the moving target indicator, class A moving target indicator, or MTI radar system. Then the second one is called Doppler pulse radio frequency radar system. So those are the two types of pulse or types of pulse of radar system. So then, if that's the case, we can just have a tree diagram here. Can present those information in simple so it's simple. Just see within 3 seconds. Stop writing and stop writing. So he said that here we have the word radar. I said stop writing, look and listen what I'm summarizing there. So this is the summary about primary radar system. So we say that we have two categories of of radar system. The first one is called the primary radar system. The second one Secondary what? Secondary what? Secondary what? Radar system. Then we discussed about primary radar system. How many tests do we have? Two. The first one is what? Pardon? Continuous. Continuous what? Continuous. Continuous RF radar system or primary radar system. The second one, the second type is what? Pulse. Pulse what? Pulse radio frequency what? Primary radar. Then in continuous radio frequency radar system, we have two types, which is the last category. The first one is called what? Modulated. Modulated what? Modulated continuous wave radio frequency primary radar. And here we have what? Unmodulated. Unmodulated continuous wave radio frequency primary. I think that primary radio frequency wave radar. Primary radio frequency radar system. And then here we have two categories. The first one is called what? Moving target what? Indicator. MTI. But MTI what? Pulse. Pulse what? Radar system. Or primary radar system. Then for this part, we have what? Doppler what? Doppler pulse. Pulse radar system or primary RF radar system. So these are the types. So you see we have two types of radar system. We have two types of primary radar. We have two types of continuous. We have two types of pulse. So later on we'll discuss about secondary radar system. So listen. From these types of radar system, you might, I think that you have noticed something. This is analog signal, this is digital signal. So when you hear the word continuous, you hear the applications of the continuous signal, where we apply in telecommunication engineering. When you hear the word pulse, you hear that the applications of 40 of the pulses. You have to review about pulses in order to understand how is these pulses are being propagated to the distant target and being reflected as the echo. Okay? Any question about what you have drawn there and what you have discussed? Ask a question about what I've introduced to you there. So, okay, the next part we'll be discussing about types of the secondary radar system. Then we'll be discussing in detail about what is primary radar, what is continuous radar, what the pulse RF primary radar. So in case of block diagram, this one has its own block diagram, 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 block diagram. So how many block diagrams do you have there? So go and find it. We have discussed about the different types of the primary radar. Then we drew the three diagrams that shows the two types of radars and also the categories. So different just means the further classifications of the primary radar. So today, let us have a focus on the secondary surveillance radar. So let me just give you this note, not before. The primary radar is also known as primary surveillance primary surveillance radar. In short, we call it PSR. Class A primary surveillance radar. Say primary surveillance radar. So that's another names of 40 of the primary radar. So before we discuss about secondary radar, let me give you examples of primary radar, and then later on that will define. Okay, so then we have very important question. What is primary surveillance radar? Primary surveillance radar. This is a very important question. So there's a different way that you can define the primary surveillance radar, and this is one of them. A PSR radar, or a primary surveillance radar, or primary radar, we say that is the conventional, students, attention please, is a conventional radar sensor. This is the conventional radar sensor. Radar sensor is the conventional radar sensor that illuminates a large portion of what? Of space with an electromagnetic wave, and receives back the reflected waves from the target within that space. This is very important word. Class A primary radar. Say primary radar. Say primary radar, this is the conventional radar. It's not the military-based radar. It's a conventional radar sensor that illuminates a large portions of electromagnetic wave, which in most cases is radio frequency, and receive back the reflected. So receive back the reflected waves from the target within the space. What does it mean? We say that a primary radar, it's a radar that gives OT, that's actual for based on propagating electromagnetic waves towards a distant target, but the target should be within its range. Because when I've been teaching about examples of radio frequency, then we found that there are some radars that operate with 300 megahertz. And there are some radars which operates with the frequency, or which can that illuminate electromagnetic waves with the frequency of 2 gigahertz. And some of them, they can illuminate the electromagnetic waves of 4 gigahertz up to 8 gigahertz. Okay? So it means that it depends the capacity of the radar. So the radar cannot detect any target, but can only detect a target which within its what? Its capacity, or within its space. So what does it mean? So this is radar at this point. This is target. So it means that we can have two targets, different points. This is target at point A. This is target at point B. If this radar, its space, or yes, it means its coverage area, which is radio space, is from this point to this point, then the target at point A will be detected. But the target at point B, it won't be detected. Why? However, that it will be just radiating the electromagnetic waves towards the target. Then the targets will reflect some amounts of 40 of energy. So a target at point A will be detected, but a target at point B will not be detected. Why? Because the target at point B is out of the space. So in case that you want to detect, unless that this target B is moving toward the radar until it reaches that point A, it will be detected. But if it's moving away, wonderful. We can use another powerful radar which actually can cover a large range or a large distance. All together. But primary radar, its working principle actually radiates electromagnetic waves sent towards the target within its space, and also receive the reflected wave. That's a very important point. Because when we discuss about secondary radar, its working principle is completely different from the primary radar. Are we together? Are we together? So then we say that yes? What if the materials does not reflect the radio waves? I don't think that there are a target which cannot reflect the radio waves. A blackboard. Have you ever seen a black aircraft? Because the issue of color is also important. For instance, in most of the aircraft that you used to see in movies, what the large color, or what the highly concentrated color? White, right? If you remember the principles of light, you know that you learned about a blackboard. So blackboards, or an object which is black in color, it absorbs large amount of light and reflects less, right? But an object which is white in color, it reflects large amounts of light, right, and absorb less. That's the principle. That's the reasons why. Okay, you can find that most of the aircrafts, they have just a flag of the particular country. They have some, but I think that the highly concentrated color for the most of the aircraft that I know, whether it is military, whether it's actually we call this non-military aircrafts, they have a white color. Okay? So Mr. Komba here is trying to think that what if the material or the target, because we used to say that maybe let us focus on aircrafts. What if the target cannot reflect? Yes, we can. There's the way is also to detect it, because there's a different alternative. Okay? But mostly what we think that, or what we say, it depends. Because for instance, if let's say that you eliminate or just you send radio waves with a frequency of 8 gigahertz, you might find that the reflected one, because of the loss and whatever, you might find it's 1 gigahertz. So it's enough. So 1 gigahertz, maybe if it's a black, 7 gigahertz has been absorbed. So 1 gigahertz is enough. Matthew. Huh? Huh? So you have to know this point. The primary radar The primary radar does not depend the targets transponder. Targets radar transponder. That's a very important point. Say the primary radar does not depend the target's radar transponder. So when I will teach you about the secondary radar, because I think that the remaining part which will be paying attention is secondary radar. For the secondary radar or secondary surveillance radar, it does not depend on the radar to radiate. Stop writing. For the secondary radar, it does not work by using the principle of a radar to radiate electromagnetic waves to the distant target and wait for the reflected one. For the secondary radar, it means that this one depends on what? If the radar radiates the electromagnetic waves to the distant target, the target also has something we call the radar transponder. Say radar transponder. So it means that the radar, the targets will be interrogating with the ground-based radar. So it means that within the targets, if it's an aircraft, you'll find that it has a transponder. So that transponder, it's the one that will be interrogating with the radar. So in case of the primary radar, it doesn't need the presence of the transponder or radar transponders on the target. So the target it's not necessary to be equipped with transponder. Are we together? Okay. Then examples of primary radars. Just wait. I think that this point maybe some of you did not understand. When I'll teach about secondary radar, you'll understand that point that you have to note. Examples of primary radar. But before examples, you say that, let me just write the second point. God is reminding me the second point to note. We say that most of primary radars are civilian radars. So when you say that civilian radar, say civilian radar. So it's not, most of non-military based radars are primary radars. And most of the military radars are secondary radars. Are we together? So civilians is actual that it's a radar detecting a target, which is actual that visiting your place with a particular permission. Right? Non-civilians, we call it means that maybe it's an enemy. Because in radar system or in radar telecommunication system, we have just a friend target and a foe target, or a friend target and an enemy target. Are we together? So we just have two situations. So it means that if you report that, hello, I ask you to come. I ask you to give me the permissions to pass through your space. Then the reply is, okay, yes, you can pass. That's the friend. Okay? But once you find that, there's an aircraft that's passing through Tanzanian airspace, and without any information, that is an enemy. Those are the principles. Even in case of the oceans, these radars are actually protecting the different countries, especially on the oceans part. So if there is a ship, it has to follow, because I think that there's an international association for the radar or for the air transport that's called ICAO. Okay? So it means you have to ask permissions to cross a particular boundary of the oceans or a particular airspace of the particular country. Otherwise, you are an enemy. Those are the principles that say, okay? So most of the civilians radar, for instance, that we have Air Tanzania, that actually are traveling from JNIA or Julius Kambarage Nyerere International Airport to Kilimanjaro. So it means at Kilimanjaro International Airport, or maybe just the Air Tanzania traveling from Dodoma to Dar es Salaam. So the radar located at JNIA, Julius Kambarage Nyerere, a special primary radar, is the one that to actually be detecting them, the incoming Air Tanzania aircraft, and also giving the information to the pilot about whatever the case, or just providing the report that there's the Air Tanzania moving from Dodoma to JNIA International Airport. Are we together? Are we together, class? Okay, so examples of primary surveillance radars. So the first one is called the ground penetrating radar. Say ground penetrating radar. Again, say ground penetrating radar. This is mostly used for we call it for the oil and the mines exploration. Explorations. For instance, that if the government predict that we have underground oil in Lindi, so sometimes they use these radars or ground penetrating radars to examine, to explore if it is true we have the availability of oil, underground oil, or it's not there. Okay? And sometimes these radars, that for the ground penetrating radars, they can be actually embedded within the aircraft. So the aircraft is actually in a particular, or helicopter aircraft, or for example, that it is in particular, and hence that radar is actually sending the radio waves into the ground. Okay? So there is, I think that the target for this case will be maybe the oil or the mines. Are we together? Yeah. The second example is called the air-based search radar. Second example of primary surveillance radar is called the air-based search radar. Air-based search radar. Say air-based search radar. Say air-based search radar. Then the third example of primary radar is called the weapon control radar. Weapon control radar. Say weapon control radar. So this is your homework. Mention number 4. The 5th example of primary radar, the 6th example of primary radar, and the 7th example. So this is your responsibility. So I think that I've given you a clue about primary radar and its categories. And I think that is kind of interesting. Now, let us discuss the second type of radar, which is called the secondary radar. Because we didn't discuss about secondary radar, we discussed about primary, its types, and then we further categorize about its types. Say secondary radar. Okay? So, I think that this is number 1. We'll discuss later on about the block diagrams of the primary radar, secondary radar. We'll discuss them. I'm trying to introduce about these types, and then we'll actually discuss about them. So we have a fundamental question here, which is, what is secondary radar? What is secondary radar? Say secondary radar. So a secondary radar is a type of radar system. Type of radar system that measures the radar parameters. Say radar parameters. What do you mean? How many radar parameters do you have? Eh? How many radar parameters do you have? Mention them. Uh-huh. 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 Oh, wonderful. So this radar, or this type of radar, measures the radar parameters of the target. Of the targets equipped with a radar transponder. Equipped with radar transponder. Oh. Equipped with a radar transponder. That reply to each interrogation. To each interrogation signal. To each interrogation signal by transmitting signal or transmitting encoded data such as identity code. So this is one of the definitions of the secondary radar. Secondary radar is a type of radar system that measures or determines radar parameters of the targets equipped with radar transponder that reply each interrogation signal. By transmitting the encoded data, such as identity code. Stop writing. A secondary radar, this is the type. The one type is a type of the radar system that measures the radar parameters, means that it determines range of the target, it determines elevation angle of the target, it determines azimuth angle of the target, it determines radial velocity of the target, which equipped with radar transponder. Say radar transponder. Say radar transponder. Say radar transponder. That reply to each interrogation signal by transmitting encoded data such as identity code. So from that definition, you can notice that primary radar is not or is different from the secondary radar. Because primary radar just propagates or illuminating the electromagnetic waves towards the target. And that target is not necessary to have a radar transponder. But for this one, is actual focusing on interrogation. Say interrogation. Interrogation. Say interrogation. Interrogation. I think that we heard the word interrogative in English. Right? We have interrogative what? Pronoun or what? Huh? Interrogative what? Noun. Huh? Proper noun. Huh? You don't remember. So this is focusing on interrogation between the radar and target. It's not focusing, actually it's not focusing on transmitting the electromagnetic waves and receive the reflected one. No. So it means that these types of radar cannot detect or cannot measure the radar parameters of the targets which are not equipped with what? Radar transponders. Are we together? Listen careful, ask you questions in case that you need to understand or in case that maybe you need further information. So for this case, what do we say? Here at this point we have a radar. We have a secondary radar. Secondary surveillance, because I think that is called also secondary surveillance radar, SSR. So this is the radar that is located in a particular place. Then at this point we have target within its space. But these targets should also have something we call radar transponder. Radar what? Radar what? Transponder. So the secondary surveillance radar will be actually transmitting encoded data. Say encoded data. We'll be transmitting encoded data. So it means that when you say encoded data, those are the digital signal. So it'll be transmitting the encoded data toward the radar transponder. So when the radar transponder receives the encoded data, for instance, example of that encoded data is identity code. Say identity code. Say identity code. Say identity code. So identity code means that now we want it to identify you. Who are you? So the radar transponder will also interrogate with a secondary surveillance radar. How? Itself also will send the interrogation signal towards the secondary surveillance radar. Okay? So if the interrogations has been established, then determinations of the radar parameters will be done for that case. So the target should be equipped with radar transponder. If the target is not equipped with a radar transponder, then you cannot use the secondary radar to identify or to measure those different parameters. Because the main purpose, one of the main purposes for this secondary radar is actual for the identifying different targets that passing in a particular place. Are we together? So we say that the secondary radar. Okay, so I think that because this is figure 1 and this is figure 2, because engineering is all about diagram. This is figure 2. So these are the simple diagrams just to explain the concept. The secondary radar is also known as secondary surveillance radar. In short, you call it secondary surveillance, SSR. So students, what the other name of secondary radar? Pardon? Okay. Ask your neighbor, what the means of the word surveillance? The secondary surveillance radar is the military based radar. So this is the military based what? Based what? Radar. That's number 1. But also he said that the secondary surveillance radar is used in air traffic control. Air traffic control. In short, this one we call it ATC. Air traffic control. Air traffic control means that for air, for air transportation. Transportation. So the secondary surveillance radar is used in air traffic control. Say air traffic control. Air traffic control, it's a department that we usually find in defense operating. Air traffic control, it's one of the important departments that is found in most of the airports. Listen, students. Say air traffic control. Air traffic control. This is one of the departments, and actually it is a very crucial department in air transportation. It's one of the departments that found in most of, I think that all the airports, whether it is national airport or international airport. So listen, what is the main role of this air traffic control department? Its actual is to give very important information to the pilots. Why? Because all the pilots, whether that they are actual that in just it means that they are driving or whatever the aircraft, actual that they're huge or smaller one, they don't know that mostly that they have a physical limitation. It means that physical limitations. They cannot even see that this is the airport right now that I am. Are we together? And sometimes those pilots, they cannot know that there is another incoming aircraft in the same line or in the same track. So simply, what I want to tell you that we know about car traffic controllers. So the car traffic controllers actually that we use to find them in the particular junction, maybe actual that to just to avoid the collisions there, car collisions. For these departments, it's very important because actually it's one providing all the information to the pilot from the beginning of the journey to the end. Okay? So they can tell the pilots about the distance. Let's say that this is the route. Because in airspace, there are different routes. So these are the routes. Let's say that we have 4 routes. Okay? So suppose that this is aircraft A at this point that actually heading to, this is Dar es Salaam, and this is actually Kilimanjaro. But again, there's another aircraft from Nairobi. This is aircraft B. Okay, or aircraft B, for instance. Aircraft B passing through the same route. So in case that there is no any information to pilot of aircraft A or pilots of aircraft B, I think what you have also to expect there, you have to expect the accident, the head-to-head collision. Okay? Because the pilot is is not familiar with what is actual outside the aircraft. That's the truth. Unless you get the information from the air traffic controller. Okay? And they are using actual radio frequency, and they have the particular bandwidth for them to communicate. And they have a special language. This air traffic controller men, or because they're telecommunications and electronics engineers by their profession, they communicate with pilots in a particular language, not just like English language, because that's what makes that all the pilots worldwide, they can travel from one airport to another airport, whether they are Chinese, whether they know Japanese. So they have international language for the air navigation or for the air transportation. That's the good news. Right? Right? So the communication language is not English. It's not Arabic. It's not Swahili. It's not maybe French. It's not any popular language that you know, maybe Chinese. No. They have a special language that any air traffic controller worldwide should know that language in order to attempt or in order to actually to control the air transportation. That's the second thing, right? Right? So it's air traffic controllers. They have a display to display all the aircrafts and all the helicopters, every kinds of the vehicle that on air. They could sit, especially within that space where the radars and other navigation aids that can actually detect the target. Okay? So these air traffic controllers are the ones that has to tell pilots of aircraft A that another incoming aircraft B in the same route. So what actually they'll tell him, or they'll tell him or her, so please make sure that before you reach a particular distance, or for these times, try to move from route A, actual being in route, so in route number 1, so number 2, number 3. So actual move from route number 1, go to route number 2. So from there, it means that there's no head-to-head collision between aircraft B and aircraft A. All the aircrafts and the helicopter, they have routes just like the normal roads. They're not actually passing anywhere. The aircraft, if it's traveling from Jania Julius Kambarage Nyerere International Airport, Jania International Airport, to Amsterdam, because there are some aircraft international, to Amsterdam, say Amsterdam. Amsterdam means that where? Dutch, or Israeli we call to Hollands. Okay, some of the aircraft, they spend 8 hours in air. For instance, KLM, the British Airways, right? So when they travel from Jania, Jania, Julius Nyerere International Airport, to Amsterdam. So what actually that this aircraft will have a particular route from Jania to Amsterdam. It won't pass any route. Are you together? Are you together, students? Yeah. Remember that we will have a study visit. And one of the departments that myself I'm praying that we should be taken to, its air traffic control, because I have gone to air traffic controller of Jania. And actually it was very interesting for me. I just wanted to stay there because I saw the miracles. Say miracles. Yeah. Because in space, usually you see that, what's going on there? Are we together? So this is a very important point that you have to know. So that's why we say that this is a good radar for the air traffic control. Are we together? So most of the aircraft, if this is a good radar, the secondary surveillance radar, it's a good radar for air traffic control. It means that most of the aircraft, they have radar transponder. Are we together? We'll discuss later on about the meanings of 40 transponder. But for this time, let me just introduce it to you. But you're not limited also. You can go and check what the means of transponder, because I think that one of the vocabulary that you encountered in this class is transponder. And we're interested to know it. Because it might be small but doing great things. Are we together? Yeah. Then another point that we say that the secondary surveillance radar does not depend on transmitting the radio frequency wave from the radar to the target and receive what? And receive the echo. So this one does not depend on that mode of communications or mode of propagations of the wave signal. Let me give you one example of this radar, then we'll move to the types of 40 types of secondary radars. Secondary radars. So the example of secondary radar, example of SSR, secondary surveillance radar, is this one. It's called the identification friend or foe. In short, we call it IFF radar or secondary surveillance radar. Say identification, friendly or foe. Again, say identification, friendly or foe. Again, say it. Huh? So ask your neighbor, are you my friend or my foe? Ask your neighbor, don't ask me. So in short, we call it IFFSR. Again, another point that we say that so this is the first example. We have the second example also of SSR radar. We have also some of ground radars. And the third example, it is called the airborne radars. Airborne radars. Say ground radars. Say ground radars. Airborne radars. Say that these radars, so these radars respond when they will be interrogated by some other radars mounted on the target by using encrypted signals. So these radars respond when they will be interrogated by what? By some other radars mounted on the targets by using the encrypted signal. Encrypted signal is just like this one, encoded data. Say encrypted signal. So it means encoded data. That's what we call it in telecommunication. Encoded data. So it means that we'll have the encoder on the radar part, on the ground radar, and we'll have also the decoder on the ground radar. But on the parts of the, we call it radar transponder, also we have encoder and what? Decoder. Are we together? So these are very important information when we'll be doing the study visit to TCAA, Tanzania Civil Aviation Authority. Those are the questions that you have to ask them. And you have to ask them, can you show us? Okay? Yes. Because these are the real information that, or real concept that you are learning. Okay, so if that's the case, let us end our class by learning types of secondary radar. Secondary radars. So you say that in radar system, there are, in case you have any question, you may ask about what we have discussed. There are 4 types of secondary surveillance, radar, SSR. So there are 4 types of secondary surveillance radar. The first one is called the monopoles. Monopoles secondary surveillance radar. Monopoles secondary surveillance radar, which in short we call it MSSR. Class say monopoles. Say monopoles. Say monopoles. So whenever you hear about encoded informations, in most cases, these we call them are the digital information. So the information signal, it will be digital, because whenever we talk about passes, we talk about digital informations, or the informations in form of the digital form. Okay? Yes. So the first type is called the monopass secondary surveillance radar. Say monopass secondary surveillance radar. Monopass secondary surveillance radar. Again, say it loudly. Monopass secondary surveillance radar. Again. The second type is called the modes S. Modes S, secondary surveillance radar. The third type is called the traffic alert and collisions avoidance system. Traffic, class A modes S. Say modes S. Ladies, say modes S secondary surveillance radar. Those are the ladies in this class. Ladies, say modes S secondary surveillance radar. Gentlemen, says modes S secondary surveillance radar. Yeah, so gentlemen in this class are live. The third type is called traffic alert and collisions avoidance system. SSR. So in short, we call it traffic alert collision system. S. TAX. TAX is abbreviation. Stop writing. Class A traffic alert and collisions avoidance radar system. System radar. Say traffic alert and collisions avoidance system secondary surveillance radar. Again? Wholeness yourself? What? Condition? Accordance? Avoidance? Matthew, say it to yourself. And condition.
Avoidance system. Secondary surveillance radar.
In short, we call it what? In short, it's a CCR. In short, how do we read that abbreviation? Huh? Taxi, the one that you used to order or to board? No, tax. So tax T is standing for traffic. A is standing for? C is standing for? A is standing for? So this one is very important. Do you see your neighbor? The tallest students. So this radar is very important to avoid collision. Provide an alert and avoid collision between one target and another target in airspace. So there's a special radar to avoid collisions as how I have been teaching you at this point. Okay? So it's providing alert to who? To the pilot. Then it's avoid. Why should be collisions? Why should the collisions be avoided? Because collisions is actual cause an accident. And you know that there's the one phrase that I heard from one of my teacher, and he told me that if a medical doctor do a mistake or commit a mistake in treating a patient, you know actually what are you going to do? We are going to bury the medical doctor's mistake, but the medical doctor is alive. But if a captain commit a mistake, right, then that mistake will affect himself and what? All the passengers within the aircraft. And that's why that if you've been following different, we call them radios and televisions, different information providers, systems, it's very rare for you to hear about air accident. Why? Can you compare the air accident that you had like the road accident? Yes. How many air accidents have you had in Tanzania in this year, 2024? How many? 1, 2, 3, 4, 5. 0. Okay, how many road accidents have you had, especially that? Uncountable. So the first example of 40, the first example of, keep quiet. The first type of secondary radar system is called automatic. Say automatic. Ask your neighbor, are you manual or automatic? Manual. So this is the fourth type of secondary radar. Say automatic dependent surveillance broadcasting secondary surveillance radar. Again, say automatic dependent surveillance broadcasting secondary surveillance radar. Ask your neighbor, when you remember the movies that you've been watching, which type of the radar have you seen it? Within the aircraft, within the helicopter, or within the airport, or within the building? So ask your neighbor, which type of the radar have you seen in those movies? So for that case, then we can have, it means that we say that summary of secondary or summary of types of secondary surveillance radar. We say that we have the first block here. Which is called the radar. And then we have also two types of radar. The first one is called the primary radar. The second one is called the secondary radar. So then we have four types of secondary radar. Please, I ask you to draw what I'm drawing there, because in previous part, you forgot to draw it. The first part, or the first type, we say it is monopole secondary surveillance radar. The second type, we call it a mod S. Mod S, surveillance radar. The third type, we call it a traffic alert collision avoidance radar. Traffic alert and collision system. Then the fourth type is the fourth type of secondary radar is called the automatic dependent surveillance broadcasting radar. So you can link, so previously, in previous part, we discussed about types of the primary radar. So now you can draw the entire tree diagram, so the entire summary of the types of radar. Where that, for this part, we said we had the two types of primary radar. The first one is called what? Continuous wave. And what? Pulse radar. Then you have two types of continuous wave radar, primary radar, which is what? Modulated and unmodulated. And also you have two types of what? Pulse radar, which is what? MTI and what? Doppler. Doppler pulse radar. So for the secondary, we have these four types. These modules will be focusing on primary radar. Listen, in this module, we have just introduced you about these four types of radars. You will learn them in the next modules, especially that in your undergraduate education. But with these radar navigation aids for the ordinary diploma at the fundamental module, we are going to focus on primary radar system. Are we together? Yes. Is it clear? Yes. Is it clear? Yes. So, here it's a homework 3. Draw the general block diagram of all types of radar system. So I have asked you to go and draw a number of block diagrams, general block diagrams, for the different types of 40 of radar. There is the block diagrams for primary radar, there's the block diagram for the secondary radar. There's a block diagram for the continuous primary radar. There's a block diagrams for the pulse primary radar. There's a block diagrams for the MTI. There's a block diagrams for Doppler. There's a block diagrams for unmodulated, and there's a block diagrams for the modulated. So make sure that before we meet in the next class, you go through or you draw those different types of, those different block diagrams, because I cannot teach you about how do they operate if you don't have a general block diagram. Are we together? Yes. Did you understand the class? Yes. Ask your neighbor, did you understand what has been taught or not? Ask your neighbor, did you understand what you have been learning or not? So if you have understood, now we have our culture. This is our culture. This is our class culture. To make sure that we close with joy and we close with a shout, and actually close with the situation that we have to forget about the challenges that we have. So we used to congratulate ourselves for understanding. So I'll be counting 1 up to 3. Then you'll clap the hands and she'll be happy. So tell your neighbor, get prepared to be happy. 1, 2, 3. Hongera. Imara. Wow. Thank you very much. This is the end of workshop 3. I would like to invite you in workshop 4. Keep quiet, students. I would like to invite you in workshop 4, where actually we'll be continuing from the point where we have ended. I ask you to make sure to do this homework. It's very important because actually it makes you to be ahead of what you are going to cover. If that's the case, thank you very much. See you in the next workshop.
Hekima